code you're about to see is trash. It is absolute garbage. Do not do what I did. I don't even know if I want to make this video because literally I hate what I did. It's just bad. Just don't do this. There's like literally, if you want to watch this video for learning how to solve this problem, don't watch it. If you want to watch this video to learn how not to solve it, definitely watch it because this code's awful. Just don't. All right. Anyways, so welcome everyone to day 17 of Advent Code. Hopefully today's problem goes. I mean, I guess that's just every day. Hopefully today's problem goes smooth. I mean, I guess why wouldn't I want to say? Well, hopefully every day's goes smoothly. At any rate, day 17. We keep saying that we're due for a path finding algorithm puzzle. So maybe today's the day. I'm kind of hoping not because I don't want to do one. But here we go. One, go. Day 17. As your flight slowly drifts through the sky, the elves at Mythical Information Bureau at the North Pole contact you. They'd like some help debugging a malfunctioning experimental energy source aboard one of their super secret imaging satellites. The experimental source is based on cutting-edge technology, a set of Conway cubes contained in a pocket dimension. When you hear it's having problems, you can't help but agree to take a look. The pocket dimension contains an infinite three-dimensional grid. At every integer three-dimensional exists a single cube, which is either active or inactive. Initial state of the pocket dimension, almost all cubes start inactive. The only exception is that a small flat region of cubes are puzzle inputs. The cubes in that region start as specific active or inactive state. The energy source then proceeds to boot up by executing 6 cycles. Each cube only ever considers its neighbors. Any of the 26 other cubes where any of their coordinates may differ by at most 1. For example, given the cube at that, its neighbors include the cubes at that, the cube at okay, and so on. Any of the 26 other, why are there 26 others? Okay. Oh. Yeah. During the cycle, all cubes simultaneously change their state according to the following rules. If a cube is active in exactly 2... Okay. It's not pathfinding. This isn't pathfinding. It's the same as what we were doing before. Oh, no. Okay, so we're... Oh, that's a very simple puzzle input. I'm kind of scared now that that's that simple. What? So during a cycle, all cubes simultaneously change their state according to the following rules. If a cube is active and exactly 2 or 3 of its neighbors are also active, the cube remains active. Otherwise, the cube becomes inactive. A cube is inactive, but exactly 3 of its neighbors are active. The cube becomes active. Otherwise, the cube remains inactive. So the pocket dimension determine what the configuration of the cubes would be at the end of the 6th cycle boot process. Even the process is 3-dimensional, the initial state represents a small 2-dimensional slice of it. Okay. So this is literally going to be the exact same as what, like day 14 it was? It makes sense. And like this guy's like explains, but he just literally repeats what's on there. It doesn't make sense. Also, he did a 4 by whatever. Do you think it gets shifted? Wait. Is it getting shifted? Did they just not draw dots above it? So that's 1, 2, 3. They just didn't shift it. Oh, get me out. No. Okay, so that's annoying. So this is right. It's the fact that there should be 3 dots above this row. If that's the case, that does make sense. So, okay, well then now we have a whole nother problem because now we have X and Y coordinates that dynamically size. So we're gonna need to like redo our code because this doesn't make sense. Okay. We're gonna start fresh because I can't. We're starting fresh. I'm trying to work with this code is not going to be the solution. So let's not work with this code. Let's just redo this. Start from fresh. So this might be excessive, but I might just go with the concept of a world. All right. This is just the way I can think of to do this. This is not going to be the best way. This is going to be the overly done way, but I'm going to do this just to get a solution. So we're gonna have a world class here, and this world class is going to store locations of stuff. So we're also going to need a private class location, and each location is gonna have int x and int y. Make these public just for making life easier. X, y, z, and a char. Okay, we can go ahead and generate a constructor for this. Okay, so here's our constructor. What? No, constructor with everything in it. Okay. So our locations, they are all of our locations. New array list. Okay. Private correctly. Okay, so these are all of our locations. So what we need to do is when we load this up, we need to then add locations. So public void add location. Locations add lock. Okay, so our initial thing we're going to do is we're going to go through each string of input strings. So there's a string, and then we need to then do for, oh, we can't do this way, right? We need a y. So for int y equals 0, while y is less than input string size, y plus plus, okay. Dot get y, k, x equals 0, while x is less than s dot length x plus plus. Okay, so now we need to go ahead and create a location. Location is going to be x, y, 0, and char is going to be s dot char at x. We need a world object, world. Okay, I'm going full out object orientation mode on this. And there we go. So now we have all our initial locations added and loaded in. Fine. So now we need to go through the step of actually doing work on these. Subspacey. So for doing our work on these, we need to get our int. So we need to have some methods here. I'm going to make a vec2 here. Vec2, not 3. So vec2. So actually, I don't technically need this. I can just do int array. So we're going to need to add a method here. So public int, and this is going to be get xvals. You'll see what this means in a second. And it's going to be integer dot max value, integer dot min value. Okay, so with these in mind, we're gonna then return to return. So we need to go through each location. So for location, and locations, we need to check if location dot x is greater than, to return 0. If it is, to return 0 equals x. Again, this is probably really inefficient. I'm sure there's a much more simpler solution that I just don't know, and I'm just going to go again full object orientation mode on this. Oh, sorry, they're opposite ways around. We're finding the min and max value. So this is going to be the min value. This is going to be the max value. We're finding those values. So then we return on that, and we're good. So these are the x vals. We need a method here for the y and for the z. And we need one for z. Again, not pretty, but I'm not going for pretty right now. I'm just going for a solution. So what these methods are going to allow us to do is it's going to allow us to get our max world range. That's what we're dealing with. We just want to deal with our max world range. So what we're going to do is we're going to do for int z is going to be equal. So actually we need to get these three things. So we need to have int z range world. Whoops. Z vals. I should call that range instead of vals, but whatever. So there's our z values. Here's our y, and here's our x values. Y values. Here's our x values. So this is our range. So we're going to go for int z equals z range 0 minus 1, because we're going to go 1 bigger every time, just because it's going to be the easiest solution that's for this. And then while z is less than z range less than or equal to z range 1 plus 1 z plus plus. Okay, so there's that, and then these are all going to be identical, just with different values. So y's y, and y, and then x, and x. Okay. All right, so now we're gonna do this. So now we have this. So now we need to then do our checks we had before. So, we're also going to need a public boolean is active at int x, int y, int z, and we're going to go again through all of these. This will return false. Maybe we could check if location x equals x and location y equals y and location z equals z. Assuming all these things are good, we can go to return location c equals this thing. If it is, there we go. What? Oh, I was like, what? Why is this there? Cool. So now we have a way to know if a certain location is active. So now what we can do is we have these. So now we need again, this is why this is gonna get really inefficient. Again, do these three again. These are gonna be the offsets though. So this is gonna be z off. Luckily, it's only gonna be -1. While z off is less than -2. These are much more small running, but we do need to do these. Z off, y off, y off, y off, and last but not least, x off. Okay, and so we're going to do here is we need the int active starting at 0, and we're going to do here is we're just going to do world is active x plus x off, y plus y off, and z plus z off. If this is true, active plus plus. All right, now we get into here. So now we've searched around, we've figured out whether or not these are active, and all we got to do now is we need a new world. So this is what we got to do: is we have a world, and we got to do a new world to then. So I guess this is the new world here. Yeah, so this is our new world, and we got to test if world is active at XYZ. What we do is we set, we do a check if active equals 2 or active equals 3. So these are the rules that we have to follow. In this case, new world, add location, new location, X, Y, Z, and this is going to be active. Cool. Otherwise, new world, add it, but is inactive. Otherwise, down here, if it is inactive, we only care if it's 2, or is it 3? Exactly 3. What are you complaining about? Hey, Glowstar, thank you for the bit, man. Appreciate it. Why is this? Oh, 2, not -2. 2, not -2. What am I thinking? There we go. Okay, so now we should have new world. Now we should be good. So all that's left now is to count. Obviously, we'll need a for loop here, but after all this, let's just do this one more time. No, we can make this easier. We can just do accounts in here. We can just do an int get total active, go for each location. We can do active here. It's starting at 0. Active is going to ++. Whoops, sorry. Active ++. Only if location C equals. I don't actually know what switches these are off the top of my head. This is a really old keyboard. You can find a link down below, I believe. But it might be a little loud. Yeah, what Exa had. Okay, so now we can get total active. So now we can just do a nice system out print line of our new world get total active. Please don't fail me. 11, is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh my goodness, thank God. All right, so now we've done this. Now we've done one step. Making this do multiple steps is actually really easy because all we need to do here is we just need to do a larger for loop. In case you haven't noticed, this is for loop inception. As Oz would put it, we are building the Great Pyramids in Egypt because the indentation is literally, the pyramid is ridiculous. Okay. Oh no, I don't, not a ton. I don't like the, I should, I would answer, but I need to focus on this, sorry. I is less than 6, I plus. Okay. Good there, good there. So now we have our bigger for loop. So now we have new world, but what we're gonna have to do here with this new world is we need to set world equal to it in the end. That way we have our world always being up to date with what is actually being done. So now if we run this with the example code, we should get 112. We don't, we get 129. No. No. All right, let's do it for 2 steps. When you're active, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. No, we're off by like 1. Oh, never mind. It should be. Yeah, active is 2 or active is 3. Right, so it should be. Chat, you don't know why? I put ZYX instead of XYZ. Oh my goodness. It's a game of life thing. I don't know. Like I just can't process it in. Yeah. Get me out of this. Okay. Get me out of this. Run 6 times. Please give me the correct answer. Thank you. I was writing ZYX chat. My answer, 242. Plug it in. We did it, part 1. Oh my goodness, I'm sorry about the trains going by. What's part 2? Not 4 dimensions. No, not 4 dimensions. No. Luckily, you know what this means? We just tack another for loop on. Okay. Let's move that over to a neighbor method though. Hey Oz, you like the pyramids? You like my Egyptian pyramids here? It's awful. I hate my even I hate this, Oz. Don't worry. It's to the point where even I'm offended by this. Okay, so let's go to world. Let's post this into world. Public int get neighbor. Wow. Neighbor active count. All right. So we have this. So we just need int x, int y, int z. Okay, then we have int active plus int active equals 0. Active plus return active. Okay. So now we have get neighbor active. So now we can use this here. Get neighbor active for x, y, z on the world. Okay. So part 1's good. So what we need to do is, if it's 4 dimensions, we just simply add another for loop. We're literally just adding another thing to the location stuff. So z and then w, and z and w. Z, W, W. Okay. Alright, so all of these, I'm going to see if I can keep part 1. I hope I can keep part 1, that way I have both parts on here, but we'll find that out. 0. Okay. So, part 1, we can then copy this. This is supposed to be lap. No, this is not. Okay, so here's part 1. Actually, this should be called init world. That way I can hold the initial world. And I can do world equals init world. Okay. Alright, so now let's copy part 1 again. Post this here for part 2. Same thing, worlds is equal to init world, but now we need a 4th dimension on here, which is going to be W range. I don't have all these defined yet. So we need the W range. W values, K. So now everything in world that was just taking X, Y, and Z in are going to also need to take in. So Like these get values are just annoying to have, but whatever. Z, W, 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 and W. Okay. There's that. So now everything that had taken in these is going to need to take in another value here of W. Took in, yeah. Actually, to make these work across, because this is going to, actually, this one can take it. Some of these can't take in a W. This one can. Because this one doesn't do everything, but some of these can't take a W in. W, W, W is active. This one needs a W. So now we can pass this as W and W off. Okay, what else? Total active is fine. Neighbor active. Oh, these are actually all good. Okay. And up here, we just pass zeros in for this. Zeros in for this. But down in here, now we pass W in. Now we pass W in here. And now we pass W into these. Okay, but it's the same exact thing though, because if we search all 80, oh, and you can't forget to add the W in for this check here. Okay. But it's still 2 and whatever, right? The number of active neighbors, so the rules don't change. So run this. Oh no. And now we get into the fight of it's going to take a long time. Shockingly. Not very shockingly. I mean, I don't know what I can do to improve this. Like this code is just so bad. I mean, I don't like this code's so bad I don't know if we can even improve it. Like that's how bad it is. I am. Oh wait, we can do something a little fancy. Because we only care if we can do something here to where if we get an active if we get active greater than 3, we can just return active here. Tiny improvement. I don't see it helping a ton, but maybe. Did we get sub-second? We got sub-second, so it does help. Cache locations of the active cells. It doesn't need the previous part, but I mean, I'm only saving a minute. I'm not saving much. So. The cache locations of the active cells. I mean, I don't think this list is that long. I don't think this lock list. I don't think this is that big of a list. What I can do is I can limit these. Oh, I finished. Chat, I finished. Oh, we got the answer wrong. No, we got the answer wrong. Oh. I didn't add the check here. That's what we're missing. Yes, we do. If we look at part 1, it includes the corners. So like, this is our terrible do, but it does include the corners. Neighbors, so it's any of the 26 cubes. So when we're talking 3 dimensions, it's saying any of the 26 cubes. You directly surrounding there's 3 by 3 by 3 cube is 27. Remove the middle, you get 26. So it does include the corners. So now I'm just gonna wait our minute here for this answer. Oh, no, we're backed up to 1 point. How? So it's gonna take multiple minutes now. Great. All because I added this is active check here. God, I hate this code so much. I honestly hate this code so much. I'm not sure I've ever hated the code I've written. That's why I don't want to rewrite. It should finish executing any time. I don't know what I'm gonna even do with like today's video for Advent to Code. Cause like I don't even know if I want to show off this code or any of this recording. We're at almost hour and a half. In theory, when this finishes executing, we should be done. It should take about 3 minutes, maybe, to finish executing. Maybe more. I don't know if that's gonna help though of generating a neighbor array. I don't know if that's gonna help really at all. But what might help is making this a hash map. It's a string, yeah, but making this a hash map might actually help. Oh no, sorry, not that. Sorry, hash map, yes, but of an integer. Oops. And so we just need location to have wait, it finished. It finished. It finished, chat. I don't care. I don't care anymore. It finished. I don't care. I don't care. We're done. Nope. 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 Get me out of today. I'm done. Nope. Nope. I do not care anymore. Code's done. We're done. Oh darn, yeah, my footage card, darn, I can't upload this to YouTube. Ah. I'm not even gonna try to explain this. It sucks. My code sucks. Don't do what I did. But this is probably the good example of what not to do, but also to, when worse comes to shove, just do something that you know you can do well, which in this case is do this very object-oriented like, and just do it, and you might just get the answers. Yeah. So, YouTube, sorry for the terrible video. I don't know how I'm gonna edit this. This is gonna be very interesting. But yeah, see you guys all for tomorrow for day 18. And hopefully this goes better than today's. I don't think we get any worse. Fingers crossed. Peace out.